So welcome back to my YouTube channel Kasturi Srinivas Sekhar classes for mathematics and statistics. In this video I am solving a numerical problem on assignment which is unbalanced in nature. Unbalanced problem is what? When it is not a square matrix, then it is called an unbalanced assignment problem. For getting the solution, first of all it is converted into a balanced problem. After that we will solve the given question. Let us see with the help of a numerical question. We have 5 jobs and 4 workers. What is given in the question? Assignment cost is given. Let us see the assignment cost here. 25 rupees, 18 rupees, 32 rupees, 20 rupees and 21, 34, 25, 21, 12, 17, 20, 17, 20, 32, 16, 20, 28, 20, 16, 27. This is the given problem for us. How many jobs are there? 5 jobs are there. How many workers are there? Only 4 workers are there. So it is an unbalanced assignment problem. To solve this question by Hungarian method, first of all I have to convert this one into a balanced question. For this, introduce a dummy worker with ₹0 as assignment cost. So this is W1, W2, W3, W4, W5. Job 1, Job 2, Job 3, Job 4, Job 5. $25, $34, $20, $20, $18, $25, $17, $28, $32, $21, $20, again $20, here it is $20, $12, $32, $16, $0, $21, $17, $16, $27, $0. First step for an unbalanced assignment problem is it is converted into an assignment problem which is converted. Let us see. These are the 5 jobs we have. Any job can be assigned to worker number 1. Any job can be assigned to first worker. When job number 1 is assigned to first worker, assignment cost is coming out to be 25. When job 2 is assigned to first worker, 18 rupees is the assignment cost. When job 3 is assigned to first worker, 32 rupees is the assignment cost. When job 4 is assigned to first worker, 20 rupees is the assignment cost. When job 5 is assigned to first worker, 21 rupees is the assignment cost. This way you have to interpret the other numerical values which are given in the question. The best way of assigning the jobs is job 2 should be assigned to first worker so that my assignment cost is minimum. Instead of assigning job 2 to worker 1, if any other job is assigned to first worker, then what will be the additional cost the firm is incurring? that is called opportunity cost, which I have to calculate. So step number 1, row operation. How to do this row operation? Select the least value from the first row. 18 is the least value. Subtract 18 from each and every element of the first row. Again, I am repeating this point. Select the least value, which is 18 in the first row. Subtract this value from each and every element of this row. So 25 minus 18 is 7. 18 minus 18 is 0. 32 minus 18 is 14. 20 minus 18 is 2. 21 minus 18 is 3. So from the first row point of view, opportunity cost is calculated. Let us see this once again. Worker 1 can do any of these jobs. For worker 1, job number 2, when assigned, assignment cost is least. Instead of assigning job number 2 to first worker, any other job is assigned, then that will be the additional cost the firm has to incur. Go to the second row. From second worker point of view, I am analyzing the question. Least value in second row is equal to 12. Subtract 12 from each and every element. 34 minus 12 is 22. 25 minus 25 minus 12, 13. 21 minus 12 is 9. 12 minus 12 is 0. 17 minus 12 is 5. Go to the third row. Identify the least value. 16 is the least value. Subtract 16 from each and every element. 20 minus 16 is 4. 17 minus 16 is 1. 20 minus 16 is 4. 32 minus 16 is 16. 16 minus 16 is 0. Now go to the fourth row. What is the least value? Identify the least value. 16 is the least value. Subtract 16 from each and every element. 20 minus 16 is 4. 28 minus 16 is 12. 20 minus 16 is 4. 16 minus 16 is 0. 27 minus 16 is 11. Now fifth row is a dummy. This is as it is. Fine. We have to calculate opportunity cost column wise also. Columns will represent job. Consider the matrix obtained in step number 1. Job number 1, when assigned to worker number 1, 7 rupees is the assignment cost. 22 rupees 440. What is the least value in this column? 0. 0 you have to subtract from each and every element. It means that column will remain same. Same point you can notice for other columns also. Each column is having 0 as the least value. Therefore, same matrix I'll get once again. So there is no need to calculate opportunity cost column wise. Now let us start giving assignment. Starting with the first row, Identify the row with exactly 1 0. Identify the row with exactly 1 0. First row is having only 1 0. Assignment is given here. It means job number 2 is assigned to first worker. But look at your calculations. Job number 2 can also be assigned to worker 5. So this option I am eliminating from the picture. Because assignment is always on 1-to-1 basis. Assignment is always on 1-to-1 basis. That is, a job is assigned to one worker only. That is, same job cannot be assigned to more than one worker. Clear? Now go to the second row. Second row is also having 1 0. Assignment is given. Job 4 is assigned to worker 2. But I can also assign job 4 to worker 4 and worker 5. These options are eliminated. Third row is having only 1 0. Assignment is given. Fifth job is assigned to third worker. So fifth job cannot be assigned to any other worker. So other options this job is having are eliminated from the picture. Look at the first row, assignment is over. Second row assignment over, third row assignment over. Fourth row assignment is not possible. Reason is very simple. There is no 0 at all. Fifth row is having 2 zeros. It means job number 1 as well as job number 3 can be assigned to fifth worker. So let's go assignment procedure from column wise. First column is having only 1 0. Assignment is given. It means job number 1 is assigned to fifth worker. But job number 3 can also be assigned to fifth worker. That option I am eliminating. Now second column already assignment is over. For third column we cannot give assignment. Reason is very simple, there is no 0 at all. Fourth column assignment over, fifth column assignment over. When will I say the solution is an optimal solution? When each row and column has an assignment. When each row and column has an assignment, then only it is called an optimal solution. Otherwise not. Clear? Look at this. Fourth row does not have an assignment. Same way, third column also does not have an assignment. Then what will we do? I have to create additional zeros in fourth row as well as in the third column. Otherwise, I have to shift the positions of zeros from one cell to another cell. Is it clear? For this, the procedure is draw minimum number of vertical and horizontal lines. Again, I am repeating this point. Draw minimum number of vertical and horizontal lines to cover all the zeros at least once. With the help of this horizontal line, 5 zeros are covered. Next, vertically for fourth column another line is drawn so that 2 zeros are covered. Now there is 1 0 in the second column, 1 0 in the fifth column. Draw vertical lines here. Draw vertical lines here so that all the zeros are covered. After that, what will I do? Very simple. Select the least element which is not covered by the lines. Select the least element which is not covered by the lines. 4 is the least element. Then after selecting this least element, what will I do? For that, let me prepare this table. Look at the position of this table. That is the matrix obtained in step number 1. There are some elements which are free from the lines. There are some elements through which a line is passing. There are some elements which are at the intersection of the lines. The least number which is not covered by the lines is subtracted from the elements which are free from the lines. Again I am repeating this point. The least number which is not covered by the lines is subtracted from the elements which are free from the lines. 7 is free from the line. 7 minus 4 is 3. From this 0 a line is passing. Leave it as it is. 14 is free from lines. From 2 a line is passing. From 3 also a line is passing. 22 is free from the lines. 13, from 13 a line is passing. 9 is free from the lines. From 9 4 is subtracted. From 0 a line is passing. Therefore, leave this 0 as it is. Again from 5, a line is passing. 5 you keep it as it is. Go to the third row. 4 is free from the lines. Therefore, least value is subtracted from 4. From 1, a line is passing. So it will remain same. Again 4 is free from the lines. So from this 4, least value is subtracted. From 16 and 0, a line is passing. Therefore, those two elements will remain same. Fourth row, first element is free from the lines. Therefore, 4 is subtracted. From the next element, a line is passing. So that 12 will remain same. Next element 4 is free from the lines. Therefore, least value is subtracted from 4. From 0 and 11, a line is passing. It will remain same. Next, sir, go to the fifth row. From the first 0, a line is passing. This 0 will remain same. Next 0 is at the intersection. Next 0 is at the intersection. Therefore, to this 0, least value is added. Go to the next one, 0. A line is passing. It will remain same. Next 0 is at the intersection. Least value is added. Next 0 is at the intersection. This way a new matrix is obtained with some additional zeros. Count the number of zeros before drawing the lines. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now count the number of zeros after drawing the lines 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So one additional zero is created. Now start giving assignment. First row is having only 1 0. Assignment is given here. Put a square over this. This column does not have any zero. Therefore, unique option you have for assigning second job to first worker. Go to the second row. There is only 1 0. Job 4 is assigned to worker 2. But there is one more 0 in this column. It means job 4 can also be assigned to fourth worker. So this option is eliminated. Third row is having 3 zeros. I am leaving it. Fourth row is having 2 zeros. Fifth row also having 2 zeros. When any row is having more than 1 0 means multiple options are available. Let's move column wise. First column is having 3 zeros. Second column is having already assignment over. Third column is having 3 zeros. For fourth column already assignment over. For fifth column there is only 1 0. Put an assignment here. Put an assignment here means put a square over this 0. It means this job is assigned to this worker. Job 5 is assigned to third worker. Job 5 already assigned to third worker. But your calculations are saying job number 1, job number 3 can also be assigned to worker 3. These are two options I am eliminating. Now, fourth row and fifth row, each one is having 2 zeros. So, arbitrary selection, multiple solutions. Multiple solutions. Let us see here. W1, W2, W3, W4, W5. Job 1, job 2, job 3. 3 0 10 2 3 18 13 5 0 5 0 1 0 16 0 0 12 0 0 11. Finally it is 0 4 0 4 4. Same table one more time produced here. Up to this the procedure is same. Solution 2 here. Now what I am doing? Job number 1 I am assigning to worker 4. Job number 1 I am assigning to worker 4. It means same job cannot be assigned to any other worker. So this 0 is eliminated. Go to the third column. Job number 3 is assigned to worker 5. So the same job cannot be assigned to any other worker. This is one way of giving assignment or one way of selecting the zeros when each row is having more than 1 0. Come to this. This time job number 1 I am assigning to worker 5. Since this job cannot be assigned to any other worker, therefore this option is eliminated. Job 3 I am assigning to worker 4, and this job cannot be assigned to any other worker. This is eliminated. So there are two solutions it is having. That is, this is an assignment problem, that too unbalanced assignment problem with multiple optimal solutions. Look at this: job, worker, cost. Job number 1 is assigned to worker 1. Job number 2 is assigned to worker 1. Job number 1 is assigned to worker 5. This means this job is W5 is a dummy. Job 3 is assigned to worker 4. Job 4 is assigned to worker 2. Job 5 is assigned to worker 3. Here job left is equal to J1. Now see the assignment cost. J1 is assigned to worker 5. There is no cost at all because worker 5 is a dummy. Job number 2 is assigned to worker 1. 18 rupees assignment cost. Job number 3 assigned to worker 4, 20 rupees. Job number 4 assigned to worker 2, 12 rupees. Job number 3, this is job number 5, assigned to worker 3. Job number 5 assigned to worker 3. ₹66 is the assignment cost. Let us go here: job, worker, cost. Job number 2 is assigned to worker 1. Job number 2 assigned to worker 1, cost is 18 rupees. Next, job number 4 is assigned to worker 2. Job number 4 is assigned to worker 2, 12 rupees. Job number 5 is assigned to worker 3. Job number 5 is assigned to worker 3, 16 rupees. Next, job number 2, 4, 5 over. Next, job number 1 is assigned to worker 4. Job number 1 is assigned to worker 4, 20 rupees. Finally, job 3. This is job left, assigned to worker 5, no assignment cost. 66 rupees. Optimal value is same for both the solutions. Optimal value is same for both the solutions. So in the exam, when I am doing the question, how can I identify whether the question is having a unique optimal solution or multiple optimal solutions? Logic is very simple. When two or more rows having more than one zero, then multiple solutions are possible. Clear? So that's all in this video. In the next video, we'll meet again with some more questions. Thank you.